Yeah, so we'll start uh, today's session. So, good afternoon, all. Welcome to the discussion session, fourth week. Uh, this is today we are going to discuss questions related to the assignment number two. So, without more delay, let's start. Yeah, so the first question is: in Navier's method for a rectangular plate of dimension a by b, the following series is taken for the solution when the origin is at one of the corners of the plate. So we are given with these four options. So what is there in the Navier's method? So we are given with a rectangular plate simply supported at the edges, and the origin is at one of the corners, and the dimension is, suppose if it's this, uh, yeah, so suppose this is x equal to a and this is y equal to b. So if this is the condition, what do we have the boundary condition? So on at x equal to a, we have boundary condition as w equal to 0 and del square w del x square equal to 0. Similarly, at x equal to 0, we have, okay, so if you take this as 0, this as a, so w equals to 0, and similarly del square w del x square equal to 0. So their boundary condition we have at y equal to 0, we have w equal to 0, del square del to y equal to 0, and at y equal to b, we have, so we have these four conditions. So if we substitute this, so let's check one by one. So if we see the first option, it's given ym sin m pi x upon a. Okay. So the option A will give at x equal to 0, we will get x w equal to 0, and del square w del x square equal to, that is also 0. So this satisfies this condition. At x equal to a, will get this condition as well as this condition satisfied. But these two conditions won't be satisfied as this is not given. So this won't be our option. Likewise, a second option will also be not there. So if we see the second option and substitute all these four conditions, this will be satisfied. So the correct answer is option C. Now what if I change the um, condition geometry? What if we have a plate where this is x, this is y, and this is b, and this is a. So everything would be same, boundary conditions are the same, except this would be, so w would become amn. So along the x direction, we are dependent on this b condition. So amn sin m pi x, here it will be b, here it will be a. Okay, so let's move on to the second question. So there is a plate simply supported along all edges carrying transverse load P. The reaction at corners R naught is given by. So this is we are given the plate, so now x, y, z. So we have the twisting moment mxy. Here we have myx. This mxy, mxy, x. Yeah. So this mxy times dx is replaced by a couple with the same. Like if there is a moment mxy here, the x is the difference. So we take this as mxy and this as mxy. So that the force will cancel. We'll take the force, this will cancel out and the result moment will get. So this gives us mxy, 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 mxy. Likewise here mxy, mxy. This goes on. So if you see at the corners, so this the corner force, this we take it as R naught. So R naught is equals to 2 times of mxy. The correct answer would be option B. I hope it's correct. No issue is there. Now the third question. In Navier's method, using double trigonometric series for a rectangular plate, convergence of the deflection is faster than bending moment. So, as this has been already shown in the lectures, it is true. This statement is true. Now, solve fourth question. So, there is a simply supported plate. This is a square plate of size A, which carries a load is given by qxy, q equals to q sin pi x by a sin pi y by b. Taking m equal to n equal to 1 in Navier series and given d is the flexural rigidity of the plate, then the deflection at the center is. So we know so we are given with q of xy is equal to q sin pi x by a sin pi y by b. So we know if we take it, we have qmn as 0 to a, 0 to b, qxy sin m pi x by a sin n pi by b dx dy. We have in this case, if you see the okay, so here we have a square size plate, so b equals to a. Okay, then if we see the equation, there is a coefficient as 1 equal to n equal to 1 for the loading condition. So we will get q11 is equal to 0 to a, 0 to a, qxy sin pi x by a sin pi y by a dx dy, and qxy is sin pi x by a sin pi y by b sin pi x by a sin pi y by b dx dy. So this can be simplified as q sin square pi x by a sin square pi y by b dx dy, which is equals to q can be taken out and 0 to a sine square phi x by a dx, and 0 to a sine square pi y a dy. So if we, this integration value would be equal to a square by 2. Similarly, this will give me a square by 2. So it will be equal to q, sorry, a square not a by 2, a by 2. So this will give me q a square by 4. So we have q11 is equal to q a square on 4. Okay. So what we need to find is the deflection at the center. Now let's go to find the center deflection. So wxy, we have a series amn sin pi x by a sin pi y by b. We have m equal to n equal to 1 and equal to b. So this is equal to a 1 sin pi x by a sin pi y by b. Okay. So we have this a11 value found out as 4q11 upon d pi to the power 4a 2a square upon 2a square whole square, where d is the flexural rigidity bhq 12 1 minus nu square. Now so if we simplify this, what do we have? So q11 d by 4a square a to the power 4, 4 cancel out, this gives a square. So this is equal to q11 a square d to the power 5. So this is my a11. So a11 we have as q11 a square d by 4. Now if we substitute this in the equation for the deflection, so we'll have wxy as q11 a square d by 4 sin pi x by sin pi y by a, and we have the value of q11 as q a square upon 4. So this gives me q a square upon 4 a square d by 4 sin pi x by a sin pi y by a equals to q a to the power 4 4 d by 4 sin pi x a sin pi y by a. So we need to find the deflection at the center. So to find the deflection at the center, just substitute x equal to a by 2 and y equal to a by 2 in the equation, and what do we get as q a to the power 4 4 d by 4. This will be a by 2, this gives me 1, this will also give me 1. So finally answer is q a power 4 4 d by 4. So answer is q a power 4 d by 4, option D. Hope this is resolved, there is no doubt. So let's move on to the question. So we need to find the shear force at x equal to a by 3, y equal to b, and the shear force qx is given by alpha times qa, where we need to find the value of alpha to the 4 decimal place. And this is similar to the class, the taught in the class. So what will have the double trigonometric series as n a mn sin m phi x by a n phi y by b. We take m equal to, we just take the first series, m equal to n equal to 1. Then we get wxy as a11 sin pi x by a and pi y by b. So del w by del x will have pi a, okay, this will write a11, this will give me cos pi x upon a sin pi y by b, and the differentiation will give me pi upon a. Finally, del square w by del x square will give me minus a11 sin pi x by a sin pi y by b. This will become pi by a whole square. Similarly, if we solve for del square w upon del y square, it will have del minus a11 sin pi x by a sin pi y by b. This will be pi b square. And we know what is the shear value of qx. It's given by the del by del x or del square w, right? And this is what del square w by del x square plus del square w by del y square. This is equals to del square w del x cube plus del cube w del x del y square. So let's find this. Del cube w del x cube is equal to this becomes minus a11 cos pi x by a pi by b pi by a cube, and this will give me del cube w del x del y square is equal to minus a11 sin cos pi x by a sin pi y by b pi by b whole square times pi by a, getting from this part. So when we take the sum, what will it give me when we take the sum of these two terms? So these are common. We'll get 1 cos pi x by a sin pi y by b. Common terms are, okay, we can take pi by a whole square also, pi by a, then pi by a whole square plus pi by b whole square. I hope there is no typo in this thing. Okay, So this will be resolved as d a11 pi by a cos pi x by a sin pi y by b term pi by a whole square plus pi by b whole square, right? Okay. So we need to find the value of qx. Qx at a by 3 y equal to a. So qx at x equal to a by 3 y equal to b by 2. We have the value of qx as d a11 pi by a cos pi x by a sin pi by b by a square. And we substitute a by 3 here, b by 2 here, we get d a1 pi by a cos x equal to a by 3. This gives me cos pi by 3 and this gives me pi by 2. So cos pi by 3, this is equal to 1 by 2, this is equal to 1. Pi by a. Okay, so this can be resolved as pi to a pi a whole square pi by b whole square. Okay, now we take b equals to a by 2 here. Have I made any mistake somewhere? I think so. Okay. So what do we have the value of a11? A11, we for a UDL uniformly distributed law, we have the value as 16q d pi by 6 1 by a square plus 1 by b square, right? So when we substitute b equals to a by 2, we'll get 16q d by 6 so this is 1 by a square plus b by 2 a by 2, this gives me 4 and whole square equals to 16q d by 6 5 25 e to the power 4. So this is my a11. Substituting it, finally we get the value of qx at x equal to a by 3 and y equal to b by 2 as d by 2a pi by a whole square, then equal to a by 2 pi by a whole square to 16q e to the power 4 d pi 6 25. So we have pi by 5 cancel out and 16. So they'll have 2 to the 4 5. Here we'll get this value will give me 525 pi by 4 a square. So a square will cancel out this, so this will be finally a. D will cancel out. We have pi 4, pi, this remaining pi, and 25 cancels this, and 2, and this is 8. So finally we have the qx value as 8q upon 8qa upon 2 to the 4 5 pi. So if we simplify 8 upon 5 pi qa, so what is the value of this 8 upon 5 pi? 8 divided by 5 divided by 5. So this is equal to 0.50929, and we had to 4 decimal place 509. Okay, so this is equal to 0.5093 qa. So alpha value is 0.5093. Okay. Now let's solve the next question. So we have a plate of thickness 8 mm with size of 1 by 1.5 meter, carries two concentrated loads P1 equal to 5 kilonewton and P2 equal to 8 kilonewton at the coordinates 0.4 meter, 0.8 meter and 0.75 meter, 0.6 meter respectively. Using direct delta function and only first term of the Navier series of the value of Qmn in kilonewton correct, value of Qmn in kilonewton correct up to second decimal places will be. So for this, what we have for concentrated load, so for any concentrated load like suppose we take here as x1 comma y1. So here we have a concentrated load P. So this is given as this. Due to this due to a concentrated load P acting at x1 comma y1, we have Qmn equals to 0 to A, 0 to B, P direct delta x minus x1, because okay, and y minus y1, and similarly sin m pi x by a sin n pi by b dx dy. Okay, so if we solve this we get, okay, so we have been given a condition only first term of the Navier series, so we take m equal to n equal to 1. So if you simplify this, we'll get sin pi x1 upon a and sin pi 1 upon b. If we solve this as this, this. Now we are given with the two concentrated problems, sorry, two concentrated forces P1 and P2 with the different loading coordinates. So let's take so with the use of principle of superposition. So with the use of principle of superposition, so QMN can be found using the contribution through P1 and P2. So we directly cannot write. So for P1 we have x1 equal to 0.4 and y1 equals to 0.8, and for P2 x1 equals to 0.75 and y1 equals to 0.6 meter. So the contribution we can write as P1 sine pi times 0.4 upon A sine pi 0.8 upon B plus P2 sine pi 0.75 upon A and sine pi 0.6 upon A B. So we have A equal to 1 meter and B equal to 1.5, and P1 equals to 5 and P2 equals to 8. So it can be simplified. Qmn is equals to P1 sin pi, P1 5 sin pi 0.75 on 1 sin pi, sorry, 0.4 sin pi 0.8 upon 1.5 plus 8 sin pi into 0.6 upon 2. This gives me, okay, so 0.4 by sine 0.4 to pi, so 5 times 0.951 to sine 0.8 to pi. This first term gives me 4.7.292, and the second term it will be sine 0.75 times pi times sine 0.6 into pi divided by, this is 1.5, 1.5, right? Yeah. So 8. This is 5.3799. Adding will get 4.7292. 10. 0.1091, and we have to find up to second decimal places. So this can be simplified 10.11 kilometer. So this is my answer. Now let's solve this question. There is a simply supported plate with dimension A by B which carries a UDL Q over the entire plate. Poisson's ratio is given as 0.3. Consider here again we need to consider only the first term of the series, and A by B value has been given as 1.2. We need to find the ratio of mx upon my at the center and correct up to 3 decimal places. So for a UDL, this WXY can be directly written as 16 Q naught, or here the value we have as Q sine pi x upon A sine pi y upon B upon D mn pi 6, so 1 upon A square plus 1 upon B square whole square, right? Okay, so for mx we have minus d del square w upon del x square plus mu del square w upon del y square. And for my we have minus d del square del w del y square plus mu del square w del x square. So for this we need to find del square w and del x square will be equals to, so taking 2 time differentiation it will give me 16q d by 6 a square plus 1 by a square whole square times, if we take 2 times differentiation with respect to x, we'll have minus this sine pi x by a sine pi y by b and times minus pi by a whole square. Similarly, del square w by del y square, it will be equal to 16q d pi 6 1 by a square plus 1 by b square whole square is minus sine pi x by a sine pi y by b and pi by b whole square. So if we take this times addition, okay, so the ratio value, okay, so if you take mx upon my, it's equal to del square w upon del x square plus mu del square w del y square. So if you see the first term, this term, this term, and this term and this term same. So this will, if you take this term as a or rather than take b, b equals to minus 16q d p by 6 a square plus 1 by b square. Then del square w by del x square can be written as b by a whole square Del square W upon del Y square can be written as V pi by V whole square. Okay. So substituting these values here, we get B pi by A whole square plus mu P pi by B whole square, B pi by B whole square plus mu B pi by A whole square. The B cancel out and pi square B also cancels out. So we'll have 1 by A square nu 1 upon B square, 1 upon B square plus mu 1 A square. So if we take A square as common, so A square as common, we'll get 1 by A square as common, we'll get 1 plus mu A square by B square. And similarly, if we take 1 by A square as common, here we'll have A square by B square plus mu. So this cancel out, we have 1 plus mu A by B whole square, A by B whole square plus mu 1 plus mu value we have as 0.3 and A by B value as 1.2. 1.2 plus 0.3. So this will give me 0.3, 1.2, 1.2 plus 1, 1.432, right. Point 82298. So correct up to 3 decimal places can be simplified as 0.823. So the ratio of mx upon my is equal to 0.823. Okay. Now the last question of the day. So there is a rectangular plate simply supported along all the edges. Sides A equal to 1 meter and B equal to 1.5 carries a concentrated load P equal to 10 kilonewton at the coordinates is. Reflection is expressed by Navier with only first term as this, where A value is given by this. The original coordinate is equal to determine bending moment. So what do we need to find? We need to find the magnitude of mx at the center. So for this, what do we have? We are given with W as A sin pi x by A sin pi y by B, and a concentrated load P equals to 10 kilonewton. So as I showed you earlier, we have to take only the first term. So again we'll take m equal to n equal to 1. So q11 will be equals to, okay, so first qmn 0 to A, 0 to B, P at x1 and by y by b dx dy can be simplified as p m pi x1 sin m pi x1 by a sin n pi y1 by b. As we are given with m equal to n equal to 1, so q11 is equal to b sin pi x1 upon a sin y1 upon b, where x1 value is equal to 0.4, y1 is equal to 1.8 meter, a equals to 1, b equals to 1.5 meter. So this is equals to 10 sin pi 0.4 upon 1 sin pi 0.8 upon 1.5. So 0.4 sin 0.4 to sin 0.8 into pi to 10. This gives me 9.458 kilonewton. Okay, so we have the value for q1. So if we see for q11 and q11 is equal to q1. Now to find mx, what do we have? Minus d del square w del x square plus mu del square w del y square. We have w as a sin pi, w as a sin pi x by a sin pi y by b, and a value we have for q1 d by 4 b by a square plus 1. Now substitute, and q1 equals to 9.458. Now substitute the values of to get the value of a. 4 into 9.58 d by 4. A value we have 1, this is 1.5, 1, 1.5 square, 4 into 9.458 d by 4. So this is 4 by 9, 1.5, so 2.0864. So this will give me 0.4 into 1.5 number is into 4 into 9.458. So this gives me 0.1241 upon d. A value we have. So if we substitute, so del square w del x square will have, we have w as there, we'll get del square w del x square as minus a sin pi x by a sin pi y by b pi by a whole square, and del square w del y square is equal to minus a sin pi x by a sin pi y by b, basically pi by b whole square. So we have to find mx at the center. Center is it? Okay, so for the center, what we need to substitute, x equal to a by 2 and y equal to b by 2. So first of all, mx value will come out to be minus d minus a sin pi x by a sin pi y by b pi by a whole square plus new minus a sin plus new minus a sin pi x by a sin pi y by b pi by b whole square. So if we take a common out, so mx is equals to, this becomes a d sin x by a sin pi by b pi by a whole square plus new pi by b whole square. So if we substitute the value of a, we'll get 0.124 sin pi x by a sin pi y by b pi by a whole square plus new pi by b whole square. We have mx is equal to 0.124 sin pi x by a sin pi y by so mx value at center equals to mx at x equal to a by 2 and y equal to b by 2. This gives a 0.124. The sin pi by 2 sin pi by 2 pi by a whole square plus a by b whole square. So this is equal to 1 and pi square so this is 5. So this is equal to 1.767, and we had to find up to 3 decimal places, so this can be written, so mx can be simplified as 1.768 kilonewton meter. Yeah, so this is what I thought for today. This solves the problem. Do you guys any have doubts? So you can ask. If it is clear, Is it clear? If you have doubt in any of the question, you can ask me. Or shall we close the session for the day? Superjit, can you reply? Yeah, hello. Do you have doubt in any of the problem? Shall we close the session? Can I get any response? Subhajit? Uh, so, shall we close the session? Okay.